What is up, everybody? Welcome back to the Maths Guy. My name is Matt, and today we're going to be doing something pretty exciting. We're going to go back in time and look at the 2022 Test 1 maths paper, which is the arithmetic paper. Now, what I would recommend at this point is to download and print the test yourself. I'll put a link in the description below. Give yourself no more than 30 minutes to try and do as many of the questions as possible, and then come back and we'll work through the questions together. You'll see how many you got right, and you'll see which ones you have to have a little bit of a practice at. But if you don't want to do that, you can just follow with me and we're going to have a little go at doing them all together. So let's not waste any time, let's jump into it. Okay, now the first thing to say is that a lot of these questions are going to have multiple different ways of solving them. You only have half an hour to do this test, so you really want to try and find the quickest and most efficient way of solving these questions. So with that in mind, if we have a look at question 1, we can see that this is an addition question. We could set up our column addition, or we could try and help ourselves a little bit and notice that we have 501 and 649. So if I use the 1 from here and add it over to my 649, I effectively have 500 plus 650. 500 and 650 is obviously 1150, which is much easier to then add on to my 6155, and now I can do my column addition a lot easier. So that'd be 5, my tens column would be 5 add 5, which is 10, my hundreds would be 1, 2 and 3, and in my thousands I've got a 1 and a 6 equals 7. So my answer for question 1, 7,305. Okay, question 2, this is a great one, 0 times 989. This is going to be no working out because anything multiplied by a 0 is going to equal 0. They're trying to trick you here. Some people will put 989 as the answer, but we should know that anything multiplied by a 0 is going to give us an answer of 0. Okay, question 3. This is an inverse question. We have 10 plus something equals 302. So we could inverse this and do 302 subtract 10 equals 292. And if we wanted to check this, we could put 10 plus 292, and then we can see that that equals 302. So my answer is 292. Okay, question 4. This says 2,400 divided by 2. Now anything that's divided by 2 effectively just means to halve it, so we're going to try and halve 2,400. Some of you will be able to see that half of 2,400 is 1,200, but if we wanted to check it, we could do our bus stop 2,400 and put our 2 outside, and we can work out how many 2's are in 2, 1, how many 2's are in 4, 2, how many 2's are in 0, 0, and 0, 0. Same answer, so our answer is 1,200. Okay, for this next one we have another inverse question. This says something plus 70 equals 485, so therefore 485 subtract my 70 is going to give us our answer. So I'm going to do a quick column subtraction. 485 subtract 70, 5 subtract 0 is 5, 8 subtract 7 is 1, 4 subtract nothing is 4. So my answer is 415. Okay, question 6. 6.48 plus 8.6. There's no super quick way to work this out, so we're going to just set up our column method. 6.48, and then what they're trying to do is trick you because they've got a different amount of decimals on this second number of only 8.6. So if you want to, you could put your titles above your numbers. This would be my ones, my decimal, my tenths, and my hundredths. And now in my 8.6 I can see I've got 8 ones, my decimal, and my 6 tens, and therefore I have this gap that I can fill with a placeholder, a 0. Now I'm just going to simply add them up. 8 add 0 is 8, 4 add 6 is 10, put back my decimal, that's really important. 6 add 8 is 14, plus the 1 is 15. So my answer is 15.08. Okay, question 7. This is another funny little one because they're trying to trick you by putting this equal sign seemingly at the start of our question. But remember, it doesn't matter which way around we put our equal sign, everything on either end will be equal. So this question is basically asking us what 240 divided by 8 is. So a couple of ways I can do it. I could look at just 24 and say how many 8s are there in 24? There are 3, but 24 is 10 times smaller than 240, so I must now make my 3 10 times larger by putting a 0 after it. Or again, I could set up a quick bus stop, 240 and 8. How many 8s are in 2? 0, roll the 2 across. How many 8s are there in 24? 3. How many 8s in 0? 0. So I get the same answer, so my answer is 30. 30 equals 240 divided by 8. Question 8 says 840 divided by 5. So what I could do is 840 divided by 10. In my head I know that's 84, but we're dividing it by 5, so I need to double my 84 because 10 is double 5. So 84 plus 84 is 168. Or again, it's a division question, so I could use my bus stop. Same answer, 168. Okay, question 9. Again, no super quick way of working this out. We're going to have to use some column subtraction. And I've got 7,306. Subtract 1,847. For the sake of time, I'm not going to bother putting my titles above these numbers because we have 4 digits in one and 4 digits in the other. So 6 subtract 7, I can't do. Now a lot of people here would write 1 as our answer, but hopefully we know that 1 is not the correct answer, because if I have 6, 1, 2, 3, 4, 5, 6, I cannot take 7 away. There's only 6 there. I can't just flip the question around and say 7 subtract 6, that doesn't work. So I have to look next door, but there's nothing next door, so I'm going to look next door again, and I'm going to take that 3 down to a 2 and borrow the whole group over to my 10s column. Now my 6 can look next door again at the 10, take it down to a 9 and borrow a whole group of 10. Now I'm ready to start with 16 subtract 7. 16 subtract 7 is 9. 9 subtract 4 is 5. 2 subtract 8 I can't do, so I'm going to look next door again, take this 7 down to a 6 and put a 1 in front of my 2. 12 subtract 8 is 4. 6 subtract 1 is 5. So my answer is 5,459. Okay, this is a nice one. 1,010 multiplied by 10. What we can do here is use our place value chart. Quickly draw a place value chart. I've got no decimals, so I'm going to start with ones, tens, hundreds, thousands. I'm going to put a 10,000s in there for good measure, and then simply put in my number, 1,010. So 1,010 has 0 ones, 110, 0 hundreds, and 1 1,000. And then hopefully we understand how to use a place value chart. If we're multiplying by 10, we can just simply move all the digits one place to the left, because that's going to get them 10 times larger. So we can move our 1 into our 10,000s, our 0 into our thousands, my 1 into the hundreds column, my 0 into the tens, but then it's going to leave me with this gap that I'm going to have to fill with a placeholder. So my answer is 10,100. Okay, question 11, 560 divided by 7. Well, again, we can see that this has this little 0 here, so we could just do 56 divided by 7, which equals 8. And then because 56 is 10 times smaller than 560, we could make 8 10 times larger by multiplying it by 10, equaling 80. So my answer is 80. Or if I wanted to, I could just do the bus stop again. Okay, question 12. Question 12 is a multiplication, but it's actually multiplying 3 digits. And what we should know about multiplication is it's commutative, which means that we can put these numbers in any order and we're going to still get the same answer. So it makes sense to work it out in an order that's going to be easiest. I would say it's in that order already, because we could do 6 times 10 equaling 60, and then 60 times 11 is 660. So my answer is 660. Question 13 is again one looking for you to notice that we have this 0, so we can use place value knowledge to work this out. And I can just look at this 108 and say 108 divided by 9. And if we're good at our multiplications, we can see that equals 12. And then again, times 10 is 120. I could quickly check this in my bus stop. So my answer is 120. Okay, 14. This is another sort of place value one, because really what we can see is 500,000 subtract 5,000. The way that I would look at this is looking at these numbers after the comma. We should know that these are all the thousands. So I could just focus on that for now and say 500 subtract 5 is 495, and then put back my 3 zeros. So my answer is 495,000. Question 15, there's no real trick to this, it's just a multiplication question. 596 times 7, so we're just going to work it out in columns. So 596 times 7, and I'm ready to start. Where do I start? I start at my smallest value. 7 times 6 is 42. Then I do 7 times 9, 7 nines are 63, plus my 4, 67. Then 7 times 5, 7 times 5 is 35, plus my 6, 41. So my answer is 4,172. Okay, question 16. This is another place value question. Any question that's multiplying or dividing by 10, 100, 1,000, etc. is just going to be using our place value chart. So I'm going to build my place value chart first of all. And because we've got decimals and I'm dividing, I'm actually only going to put my ones here because I know I'm not going to need any more than that. Put my decimal in place, tenths, 100ths and 1,000ths. And now put my number in place. I've got 2.12. And now when dividing, I'm going to be moving them down the place value chart. So this 2 in the hundreds column comes into the thousandths. The 1 goes into the hundredths. The 2 goes into the tenths. And I've got nothing in front of the decimal, so I could just put a 0. So my answer is 0.212. Okay, question 17, and this is going to be the first one that's worth 2 marks, you can see down here. And it says show your method. So it wants you to show clearly how you've worked this question out so that you get both of the marks. So this is a division question where we're dividing by a 2-digit number. So for me, it makes sense to write a little multiplication table of this 2-digit number so that we can use it to help us with the division. So I'm going to put 21, 2 21s are 42, then it'd be 63, 84, and I'm going to do one more, which is 105. Now I can use that to help me in a moment. So how many 21s are in 6? Well, there's 0, and I'm going to put my 6 next to the 7. How many 21s in 67? Well, I've got 1, 2, 3, with 4 left over. Put that next to the 2. Finally, how many 21s in 42? Well, I can see 1, 2. So my answer is 32. And I've clearly showed my workings out, so I should get both marks. Question 18, our first fraction question. And this fraction question says 4/9 plus 2/3. Well, we know that we can't add fractions unless we have the same denominators. So I'm looking to try and find an equivalent fraction of one of these, if not both, to make sure that I have the same denominators. Well, I can already see that this 3 and 9 have a relationship because 3 3s are 9. So I can actually then think about that to help me with my equivalent fraction. So I'm going to put back my 4 over 9 and we're adding it to 2/3. But I'm going to turn this 2/3 into an equivalent fraction. So I'm going to try and get my 3 to a 9. And how did I do that? I multiplied by 3. So if I multiply the denominator by 3, I then must multiply the numerator by 3. 4 times 3 is 6. So 2/3 is equivalent to 6/9. So now I'm just adding 4/9 plus 6/9. And I should know that I'm going to be getting an answer that's going to be a 9th. And I just need to add the numerators. 4 plus 6 is 10. My answer is 10/9. Now this fraction is an improper fraction. To get the mark, that's absolutely fine, but if you really wanted to show off, we could turn it into a mixed number by realizing that this is actually 1 and 1/9. Either of these is fine. Question 19 is another multiplication question, and again, no tricks to it. We're just being asked to multiply, and it's already set it out ready for us, but again you can see it wants us to clearly show our method. Okay, so really this line here is going to be answering 3 times 607, and this next line is going to be answering 80 times 607, and I do mean 80 because don't forget this 8 is in the tens column, so it represents an 80. Okay, start with my smallest values, and 3 times 7 is 21. 3 times 0 is 0, plus my 2 gives me a 2. 3 times 6 is 18. Now what I like to make sure I do at this point is clearly cross out this 2 here that I used so that I don't add it to my calculations in a moment. Now I move on to my second line, but I must make sure that I'm making it 10 times larger if I want to just multiply by the 8, so I'm going to put my placeholder. This is what people make a mistake with. They will forget that placeholder and therefore the whole question will be wrong. Remember, this 8 is in the tens column, so if we want to only treat it as an 8, we have to make the answer 10 times larger, so we put the placeholder. Okay, now I can do 8 times 7. 8 times 7 is 56. 8 times 0 is 0 plus the 5, and then 8 times 6 is 48. Make sure I cross out that 5. Now I'm ready to add up, because at the moment I've just done the individual small parts. Now I need to get a total. So 1, so starting in my ones column, 1 add 0 is 1, 2 add 6 is 8, 8 and 5 is 13, 1 add 8 plus my 1 is 10, 4 add the 1 is 5. So my answer is 50,381. And again, I'll get the 2 marks. Question 20 is another place value one, because look, we're timesing by 1,000. So I can just set my place value chart up again. But I can see I've got 100ths and tenths. So I'm going to put hundredths here, tenths, put my decimal, and then ones, tens, hundreds, thousands, 10,000s. And then I'm going to put my number in place. So it's 1 in the tens column, 3 in the ones column, my decimal, 0 in the tenths column, 5 in the hundredths column. And I'm moving them 1, 2, 3 times when we're timesing by 1,000. So here we go, 1, 2, 3. My 1 moves into the 10,000. My 3 goes into the 1, 2, 3, my thousands column. The 0 goes into the 1, 2, 3 hundreds column. And my 5 into the 1, 2, 3 tens column. But I have this little gap that I must fill with a placeholder. So my answer is 13,050. We have 2 thirds added to 2 and 1 third. So what we actually have here is a mixed number, and we don't really want to add with our mixed number, so we're going to convert this into a fraction. And what we can see is the associated denominator value is in thirds. So to get a whole we would need 3 thirds. So to get 2 wholes we would need 6 thirds. So this 6 thirds is equivalent to our 2. So now what we're going to do is add our original 2 thirds plus our new 6 thirds plus the 1 third. So our answer is going to be in thirds. We have 2 plus 6, which is 8, plus 1, which is 9. So our answer is 9 thirds. And again, even though it's an improper fraction, we don't need to convert it. That is absolutely fine. Question 22. Now we're looking at a fraction of an amount, and the amount is 30. And we're looking for 7/10 of this 30. So what we need to do first is find out what 1/10 is by dividing it by 10. So 30 divided by 10 equals 3. But we weren't looking for just 1/10, we wanted 7/10. So now we'd get 3 multiplied by our 7 equals 21. So my answer is 21. A good tip is to just make sure your answer is smaller than the number that you started with, because remember, if we're trying to find a fraction of this amount, the number will always be smaller than our answer. Question 23 is a subtraction question, and again, no tricks for this, we just need to lay it out correctly. So I have 8 subtract 5.123. Now, a mistake that people could make is putting this 8 over here above the 3, just because they're trying to line it up on the right hand side, which is what's kind of common. What we want to think about is the value of the digits, and the 8 and the 5 are both ones. Then we have our decimal, tenths, 100ths and 1,000ths. And by putting these little labels above, it helps us to just make sure we're putting things into the correct space. But we do have these 3 blank gaps, and we need to fill them with something, so we're going to use placeholders. So I'm going to put some zeros in here. Now I can begin, and this question is a little bit tricky because I have my first question saying 0 subtract 3, and I can't do it, and I can't look next door, and I can't even look next door beyond that. But this 0 can look next door, so he'll knock that down to a 7, and that'll become a 10. I'll start again with my first 0. 0 subtract 3, cannot do. So I'll look next door, can't do, look next door again, can do. So then this 10 becomes a 9, and I have a 10 in my hundredths column. Now I'll start again, 0 subtract 3, still can't do it, but at this point I can look next door, take this down to a 9. A little bit messy, really helps be super organized here and just be very conscious of what you're doing. 10 subtract 3 is 7, then I have the 9 subtract 2, which is also 7, 9 subtract 1, which is 8, put back my decimal, very important, and then 7 subtract 5, which is 2. So my answer is 2.877. Don't forget to put your decimal point. That is what people will forget sometimes, and it's a silly point to give away. Okay, question 24 is a fraction divided by a whole number, and there's actually a trick to this. So what we can do is put our fraction, 1/8, and then we're going to divide it by our whole number, which is 2, but we're going to turn 2 into a fraction by just putting it over 1. That maintains its value, still has the value of being 2, but it's now in fraction form. And what I can do now is just do the butterfly trick, which is to multiply rather than divide the numerator of the first fraction by the denominator of the second, and this will give us the numerator of our answer. So 1 times 1 is 1, and then this is why it's called the butterfly. You can see now I get the denominator and the numerator of the other one. 8 times 2 is 16, and that's our answer, 1/16. Okay, 25 is another fraction, but this time we're using addition. But what we can see is we do not have like denominators, and there's no relationship directly between these 2 and 3. So we're going to have to find new denominators and equivalent fractions for both. So let's put these in the middle, and then we're going to try and find a common denominator. And the easiest way to do that is just get our denominator from both and multiply them together. 2 times 3 is 6. And I now know that 6 is going to be a multiple of both of these because we used each of them to multiply. So now I can ask myself, how did I get from 3 to 6? Well, I had to times it by 2, so I now need to do that to the numerator, times it by 2. 1 times 2 is 2. Then on the other side, how did I get from 2 to 6? I times by 3, so I must do the same to my numerator, and 1 times 3 is 3. So my new equivalent fractions are 3/6 and 2/6. And all I'm going to do is add my numerators. 3 add 2 is 5, and the values were 6. So my answer is 5/6. Okay, question 26, another subtraction. And again, no trick for this. We're just going to have to work it out using column subtraction. I'm going to put my 1s and 10s labels ready so that I don't make a mistake. And then I'm simply going to put my 26, 2 10s, 6 1s, subtract 2.012. That has 2 1s, and then I can fill the rest in beyond that, 0.012. Put my placeholders, and I'm ready to start. And again, it's one of these where I'm going to be borrowing a lot from next door. So 0 subtract 2 I can't do, can't look next door, can't look next door again, but this 0 can look next door and knock the 6 down to a 5, giving him a 1. Again, can't look next door, but this 0 can, so he'll knock that down to a 9 and a 1. Now I can look next door for the first one, knock it down to a 9 and move the 1 across. Now I can actually start. 10 subtract 2 is 8, 9 subtract 1 is 8, 9 subtract 0 is 9, put back the decimal, make sure we always do that, and then it's 5 subtract 2, which is 3, and then 2 subtract 0, which is 2. So my answer is 23.988. Okay, 15% of 3,200. Easiest way to do this is just find 10%, and 10% would be 320. But I wasn't looking for 10%, I need 15, so I'm going to find another 5%, which will then be half of that. Half of 320 is 160, and then simply add those two together because that will give me the 15, give me 0, 8, 4, so my answer is 480. Easy. Okay, 28, 2% of 3,000. Well, easiest way would be to find 1%, and 1% would be dividing by 100, so I could get my place value chart up and physically divide it by 100. Dividing it by 100 will move them all 2 places, so 1, 2, my 3 will be in the 10s column, and I'll have a 0 in the 1s column. So I know that 1% equals 30, so therefore 2% equals 60. Question 29, we've got another show your method. So we're looking for 2 marks, and again we're dividing by a 2-digit number, so it makes sense to start with our multiplications of that 2 digits, and I've got 73. 146. And sometimes it can be quite hard to find the next multiple, so you can just simply do an addition question if you wanted to. 146, add 73, 6 and 3 is 9, 4 and 7 is 11, 1 and 1 is 2, so I'd have 219, and I know the next one is 292, and the next one after that 365. Okay, I'm going to leave it at 5 for now, hopefully we won't need any more. So let's begin. 73's into 3 will go 0, put the 3 across, 73 into 30, again 0, put the 30 across, and 73 into 306, well I can go 1, 2, 3, 4, can't go further than that, so I've got 4, and then how many did I have left over? Well, I was looking for 306, and I got to 292, so I can see the difference between the two is 14. So a remainder of 14, and then 73's into 146 goes exactly once and twice, leaving my answer of 42. Okay, question 30. 80% of 115. Well, with any percentages, it's easier to just work out 10%, so let's do 10% of 115 will equal 11.5. If you can't see that in your head, just do your place value chart, and then we're going to multiply it by 8. So first I'll multiply 11 times 8, which is 88, and then 0.5 times 8, which equals 4. Add the two together, 92. Giving me an answer of 92. Okay, we're getting towards the end now. Question 31, 2/7 minus 1/9. And again, unlike denominators, so we're going to need to find equivalent fractions. So let's put it in the middle, 2/7 minus 1/9. Remember, the trick for finding those common denominators is to just get a multiple of the two of them, and we can always do that by multiplying them together. 7 times 9 is 63. So then how did I get from 9 to 63? I had to multiply by 7. So I'll do that to the numerator 2. 1 times 7 is 7. And then how did I get from 7 to 63? I times it by 9. So I'll have to do that to the 2 as well. 2 times 9 is 18. So now I have 18 63's, subtract 7 63's, which is 11 63's. And again, don't worry about simplifying or anything like that. Even if it's possible, just get the answer. Question 32, we have another mixed number. So remember, we're going to have to change this mixed number into a fraction, or specifically the whole number. So looking at my fraction, it's in halves or twos. How many halves make a whole? 2. So how many halves make 2 wholes? 4. So we've got 4 halves representing my 2. Added to my 1/2 gives me 5 halves. So this mixed number, 2 and 1/2, is equivalent to 5 halves. And now I can just do 5 halves, subtract 2/3, and I can see again I'm going to need to find some common denominators because 2 and 3 are different, and a common denominator of both would be 6. I'll do them over here this time. So to get from 2 to 6, I times by 3, so I'll do that to my 5, which is 15, and to get from 3 to 6, I times by 2, so I'll do that to my 2, which is 4. Now I can do the actual question. 15/6 subtract 4/6 equals 11/6. And again, remember 11/6 is okay, but the mixed number would have been 1 and 5/6. Okay, 33, a multiplication, and they always like to put a load of 8s and 7s in these multiplications just to try and catch you out, because they are probably the hardest multiplications. So just take your time. If you want to write out a list of the multiples, that might help. But again, remember, this first line is essentially 7 multiplied by 4078, and the second line is 60 multiplied by 4078. Remember, the 60 is because this is in the tens column. 7 times 8 is 56. Put my small 5, big 6. 7 7s are 49, plus my 5, 54. 7 times 0 is 0, plus my 5 gives me 5. And then 7 times 4 is 28. Get rid of the small numbers because we've used them. And now I can do 60 times 4078 and show that it's 10 times larger than just the 6 we're going to work with by putting the 0 in. Now 6 times 8 is 48. 6 times 7 is 42, plus my 4, so 46. And then 6 times 0 would be 0, plus my 4 leaves me with 4. 6 times 4 is 24. Get rid of the little numbers again, and now I can just add it up. So in my 1's column, 6 and 0 is 6, 4 and 8 is 12, 5 and 6 is 11, plus the 1, 12, 8 and 4 is 12, plus the 1, 13, 2 and 4 is 6, plus the 1 is 7, 2 on its own is 2. So we have an answer of 273,226. Now if you're confident with your multiplication, the only way that you're going to drop points there is with your untidiness or presentation. So it's really important to try and be as big and as clear as possible when doing this kind of problem. Use the whole space in here if you want to, so you don't make any small mistakes. Okay, 34, we're on the last page, and we have 10 subtract 2 and 1/4. So we have a whole number, subtract a mixed number. And this actually isn't as hard as it looks, because what we can do is we can just do 10 subtract 2, which equals 8. And another way of saying 8 would be 7 and 4/4. And then if we're taking one of those quarters away, we're going to be left with 7 and 3/4. And that's my answer, 7 and 3/4. 35. This is a BODMAS question. If you don't know what BODMAS is, check out the video that I'll link above. But it's basically saying, do you understand the order of operations that we are supposed to work a question out in? And according to BODMAS, if I write it here, we have brackets, order, division, multiplication, addition, and subtraction. And as we can see, division is in front of our addition. So in this question, we're going to have to do our division first. So what I like to do is write it out step by step. So it's 6 plus 4 divided by 2. The first step is to do the 4 divided by 2, so I'd get 6 plus 2, because 4 divided by 2 is 2. And then on my last row, 6 plus 2 equals 8. And finally, last question, 4/5 times by 400. And again, this is one of those ones where they're trying to make it look really complicated, but actually it's kind of easy, because what they're saying by multiplication is essentially of. So we're looking at 4/5 of 400, which all of a sudden looks a lot easier, because I can just do 400 divided by 5 to get what 1/5 is. And again, I could use my bus stop to work that out. 4's into 5, don't go. 4's into 40, go 8 times. 4's into 0, go 0. So my answer is 80. But it wasn't just looking for 1/5, I want 4/5. So 80 times 4 equals 320. There is another way we could work this out. What I could do is 4/5 multiplied by 400, which, remember, as a fraction would be just 400 over 1. So if I'm multiplying fractions, all I have to do is go along the rows. So 4 times 400 would be 1600, and then 5 times 1 is 5. And again, you could leave this as an improper fraction, but if you didn't want to, you could work out how many 5 wholes were in the 1600 by doing 1600 divided by 5. Same answer, 320. And there we have it. That is the end of the test. So if you did go through this first and get your own answers, you'll have a score for yourself now. Focus on the ones that you didn't get right. Go back and watch them on the video and see how, again, we did that before having a second attempt. But hopefully this has been really useful for you. I know how important it is to go through these exams and be confident with them before taking on one for yourself. So hopefully this has been helpful. If it has, think about subscribing to the channel. We have daily maths videos coming out to help you. But for now, peace out.